Okay guys, here's the video for 2.6 ratios and proportions. Your homework's going to be a worksheet, right? And the worksheet that I give you in class, right? So make sure that you follow along, try and do the worksheet. If you get this really quickly, then start working on the worksheet. And if you have questions, make sure you ask me. Please, stay quiet, stay calm. Listen to the video, watch the whole thing. Make sure you pay attention. If you're not paying attention, go back and replay it. If you doze off or you're not focused, go back and replay it. Like I said, if you're not focused, then yes, it's hard to understand things. So before you say, I can't understand it, say, maybe I just don't understand it right now because I'm not paying attention. So here we go. This is going to be a quick lecture. I'm going to now lower down the lectures, but what ends up happening here is we're going to compare ratios and solve proportions. All right, ratios are things like 2 to 1, 3 to 1, things like that. So here's what they are. All right, the comparison between the number of restaurants and the number of people is a ratio, right? For every 2 eggs, I get 1 chicken. So every time I get a chicken, I get 2 eggs or things like that. So the way you read this right here, they're telling you is x to y, or it's written this way, or x over y. But see, the one that we see the most is, look, doesn't that look familiar? That reminds me of a fraction. And you're right, yeah, a fraction is kind of like a ratio in a way. So suppose you wanted to determine the number of restaurants per 100,000 people in Australia. Notice that this ratio is equal to the original ratio. Well, what they're talking about here is, right here, look, it's like, where do they get these restaurants? What the heck are they talking about? They're talking about this graph right here, or this chart is a better word, right? And so what they say is we can multiply that. They're saying for every 0.349 restaurants, so not even a whole restaurant over there, we get 10,000 people. So what they do is they're like, forget that crap. I don't want to work with decimals. So they multiply it by 10. Now the question is, why do they multiply it by 10? Well, so that way we can move the decimal point 1 over, a tenths place. So now if I multiply it by 10 though, if I multiply the top by 10, I have to multiply the bottom by 10. And when I do that, now I get 3.49 restaurants for 100,000 people. So they're saying that I have a new ratio or a new proportion, which is 3.49 to 100,000. So they're saying in Australia, if I have almost around 3.5 restaurants, it would take 3.5 restaurants to have, almost to have 100,000 people. Or for every 100,000 people, I have around 3.5 restaurants. Okay, that's just kind of an idea of what it is. I like to say, for every 1 chicken, I get 2 eggs. So then if I have 4 chickens, how many eggs do I have? I have 8. 5, 4 to 8, or 5 to 10. Right? It's just a ratio. So it says, how do we know if ratios are equivalent? So if you want, I would grab that worksheet now and I'd look at it and look at the first problems. Problems 1, 2, 3, 4, 5, and 6. And this is 2-6 skills practice. The very first problem say, determine whether each pair of ratios are equivalent ratios. Right, yes or no? That's this example, guys. This is example 1. So this is problems 1 through 8 on the homework. Alright? So here we go. This is how we determine if they are. It's kind of like reducing fractions. For example, like if I have 1/2, is that equal to 2/4? Yeah. 1/2 does equal 2/4 if I multiply by 2, multiply by 2. They're the same thing, just written differently. So that's what we're going to be doing now. Here's what they say. 2/3 is equal to 2/3. Well, yeah, 2/3 is equal to 2/3. So that one is equivalent. But what about this one? What about 16 over 24 and 2/3? Well, yes. If I multiply the 2 by 8, I get 16. Multiply by 3 by 8, both the same number, I get 24. Or, notice that the book is different. They're going, instead of multiplying, they're saying 16 divided by 8 is 2, and 24 divided by 8 is 3. Are those the same? Yes. If I can multiply or divide the top and the bottom, by the same number, then they are equivalent. If I can go backwards and forwards, they are equivalent. And that's why you see like this whole circle, all right? if I were to draw it, I would have gone like this. I would draw an arrow, what? I would draw an arrow here and here. Because that's how it should be, like the circle of life, right? It has to be that you can go backwards and forwards with the top and the bottom by using the same number. If you can do that, then they're equivalent. All right? So let's look at this one. Well, 6/10 and 2/5. Well, 2 to 6, or 6 to 2, I'm going to divide by 3. And 10 to 5, I'm going to divide by 2. Oh, crap. Look at this. They're not the same. Since I cannot divide the top and bottom by the same number, or multiply top and bottom by the same number, are they equivalent? The answer would be no. No. N-O means no. All right, let's look at this one. 1/6 and 5/30. Okay, well, we're going backwards now. So this one is times 5. This one is times 5. Oh, look at that. The top is multiplied by 5 and the bottom is multiplied by 5 to get it. So are these equivalent? Yes, they are. Okay, and that's how you would do homework 1 through 8. If you want to take a break right now and work on 1 through 8, I would do that and try and get 1 through 8 done. If you have questions, ask me. So you need an explanation, if you're like, I don't know what you're talking about, right? Ask me. I'm in class. Ask me, right? Now we're going to look at proportions, right? And the main thing is that we want to know, well, see how it's like 0.2 to 1.5, 1.2 to 9.0? So here's what happens. They say that they can label them. So if you have something like this, the middle parts, maybe this is what you would write on notes. The middle parts are called means. The outside parts are called, what do you think? Extremes. Now, are you going to remember that? Probably not, but you should try to. I haven't heard this in a long time since I was in school, but the concept is what's important. And here's what the concept is saying. They're saying that the outside, if I do extreme times extreme, that's going to equal the mean times the mean, if it works out, if it's a good proportion. And here's what they mean by that. Is they're saying, I want to see if these two are equivalent, okay? Not equivalent, form a proportion, right? Are they proportionate? So here's what I'm going to do. Well, I'm going to go with, or you might have heard this, cross multiply. And so if I cross multiply and they equal each other after I multiply, we're good. So let's do it one at a time. Let's go 2 times 14. 2 times 14 is 28. Okay. 3.5 times 8. Ooh, that's kind of hard. Let's do it. 3.5. 44. I dropped the decimal. 8 times 3 is 24. Plus 4 is 28. So I get 28 equals 28. Oh yeah. Since they are equal to each other after I cross multiply, I would say yes. Proportion. They are proportionate. Okay. Look at this one. I'm going to cross multiply. 0.3 times 2. Okay, 2.0 times 0.3. 0. 6. Okay. And then 0, 0. 2 points. So 0.6. Okay, I have 0.6 equals, let's see, 1.5 times 0.5. 1.5 times 0.5. 25, 2, 7. I have 2 decimals, so 1, 2. 0.75. Are those equal? No, they're not. So it is not a proportion. See? So if I want to check these, okay, that'd be what? Let's see. 0.2 times 0.9, 18.18 equals 1.8 times 1.8 times 0.1. Ooh, they almost look like a proportion, but they're not. No. Okay. So this is just another way besides what? See? It's a different way than doing it which way? the way we were doing it before, where we check if you multiply the top and bottom by the same. It's just another way to check, guys. So now, what they say is, how do I solve one though? What if I don't know it? And look at that, they have an x. This is where you use cross multiplication. Watch this. You're going to always go x times 5 is 5x equals 10 times 3 is 30. And now look, it's just what you've been doing, guys. Let's get rid of that 5. I get x equals 6. So now what happens? I know 6 over 10 is equal to 3 over 5. Why? I'm substituting that x back. I'm just figuring out what number is going to make this so it is a proportion. I don't want to have a number that's not a proportion, so we have to figure it out. Same with here, look. With b, and this is now this is now on your worksheet, problems 9 through 24. 9 through 24 on your homework. This example is what saves you. So now I'm going to cross multiply. Okay, it's kind of weird. Let's go one at a time. That's too sloppy. X minus 2 times 7. If you look right there, I end up having what? I have distributive again. Multiply, multiply. So I get 7x minus 14, because 7 times 2 equals 14 times 2 is 28. Now look, add 14. Cancel. 7x equals 42. Divide by 7. I get x equals 6. So now this is going to be a 6. And if I check it, look, 6 minus 2 over 14 is 4 over 14, which we say equals 2 over 7. Is it? Yeah, look, 7 times 4 is 28, 14 times 2 is 28, or you could see it as divided by 2 equals what? 2 over 7. All right? It's just a bunch of different ways. So you have to figure out which one do you like. I'm going to do one more. Here we go. R times 40 is 40R equals 8 times 25 is 200. Divide by 40. Because I want to get R by itself. R equals, what is that? 5. And now let's check it. 5 over 8, because of this right here, right? Because of the R, and I'm substituting. 5 over 8 equals 25 over 40. Well, we could either cross multiply, right? And see if they both equal the same, or I can what? I can check. Let's see, 5 to 25 is times 5. 8 times 5. Does it work? Yes. Right? It works out. Top and bottom are the same, so it's correct. We solved the right one. Okay? Now, the real world example 4 is number 25 on homework. Okay? This one right here is tomorrow. We'll probably do this one in class, or we're going to work on some more in class. Probably tomorrow. I haven't decided. We'll see how class goes. But here we go. It says, in the past 2 years, a retailer has opened 232 stores. All right? And if the rate of growth remains constant, meaning what? Constant means stays the same. Okay? How many stores will a retailer open in 3 years? So every 2 years, how many do they open? Well, every 2 years it's 232. So notice that they wrote 232 over what? Over 2, because it's every 232 stores to 2 years. But what do we want to find out? We want to know how many stores are they going to get in 3 years. But notice they keep the years together. See, stores to stores, years to years. But we don't know how many, right, in 3 years. So they put it as R. And now, how are we going to solve that? We did it already. Cross multiply. And that's what they did right here. Look, 232 times 3 is, equals 2 times R. And now what do I get? Well, 232 times 3 is 696 equals 2R. Divide by 2. And I get R equals 348. So what did I solve? Well, what I said is if everything stays constant in 3 years, how many stores am I going to have? I'm going to have 348 stores. And that's where you use proportions in real life. Okay. Now, again, this was kind of quick, but again, go back and review it and be working on the worksheet and see if you guys can solve them. You have all class. Let's see if you can get it done. All right. Let's see if you can get it done. by the end of class. If you have questions, ask me. Talk to your partner quietly. All right?